Hello and welcome. This is Noah, and in this video we are going to look at finding x-intercepts for quadratic functions when the leading coefficient is 1. We're going to start with an explanation here. We're going to take this specific function f of x equals x plus 5 times x minus 3. We'll find its x-intercepts, and then we're going to FOIL this out and then refactor it to see how we did this factorization here. So what I mean by that is that this function is in factored form right now. It's x plus 5 times x minus 3. So it's a product primarily. And so we're going to start by finding the x-intercepts. And then we'll go ahead and do the FOIL out and the factoring thing. I'll show you how all of that works. So to find the x-intercepts, we are going to set y equal to 0 and solve for x. So if I go 0 equals x plus 5 times x minus 3. Remember, f of x is the output, the y. So that's what I'm setting to 0 here. Now, what we can use in this case is the zero product principle. So let's do a quick review of that. The zero product principle says that given a times b equals 0, then we have to have either a equaling 0 or b equaling 0. One of those two things has to be true. If two things multiply to be 0, one of those two things have to be 0. Now this only works for multiplying things to 0. If, on the other hand, a times b was equal to, say, 2, then we could have a equals 1 and b equals 2, or we could have a equals 3 and b equals 2/3, or we could have a equals -7 and b equals -2/7. So there would be an infinite number of ways of getting two things to multiply by 2. However, if two things multiply to be 0, this is a special case where if two things multiply to be 0, that means one of those things has to be 0. We can only get 0 if we have 0 times something, or something times 0. So with that, we can note the multiplication in this problem. This is a times right here. So what we get with this is that either x plus 5 equals 0 or x minus 3 equals 0. So we can solve for x in both of these. I'll subtract 5 from both sides and get x equals -5. Or over here I'll add 3 to both sides. And I will get x equals 3. So I will then write that the x-intercepts are -5, 0 and 3, 0. And this is great. If we have something in this factored form, we can set the y equal to 0 and then solve for x to find the x-intercepts. However, most functions, quadratic functions, are not given in this factored form. If I take f of x and f of x equals x plus 5 times x minus 3, if we FOIL this out, then I'm going to get that this equals x squared. Go x times x first, and then outside, x times -3 is -3x. And then the inside will have a plus 5x. And then the lasts will have a -15. And we're going to really be paying attention to this form here in a little bit. We've got that minus 3x plus 5x. So we're going to come back to that. But we're going to add these together to combine our like terms and get that this equals x squared plus 2x minus 15. And so normally we would see the function in this form. We would see f of x equals x squared plus 2x minus 15, and we would be asked to find the x-intercepts to this. So if we try that here, so we set 0 equals x squared plus 2x minus 15, we would need to factor this in order to solve. Now, we could use the quadratic formula, but factoring, when comfortable with it, is the quicker, by far, way of doing this. So let's practice this. How would we refactor this? So I said a second ago that we really wanted to pay attention to this minus 3x and the plus 5x. So what we're going to do is we're going to take the negative 15. So step 1, take the c value, and create a factor tree. So I'm going to take negative 15, and I'm going to note that this could factor as 1 and 15, or 3 and 5. And one of them has to be negative and one has to be positive, because this is a negative here, and we want them to add up to a positive 2. So to do that, if I did a negative 3 and a positive 5, these would add up to a positive 2. And this negative 3 and a positive 5 is those numbers that we'd seen above, that negative 3 and that positive 5. And we want them to add up to 2 because we know that that middle term should be a 2x. So we want those two numbers to be a 2x. So when I factor this, this is going to be x, oh, I want to write these instructions a little bit more carefully. The second step, so we take that c value and we create our factor tree, and then we find two factors that multiply to equal c and add to equal b. And it's really important that we pay attention to signs. The positive, negative. So the most common way of getting a wrong answer here is to forget about whether it's a positive or negative that we're multiplying or adding to. So when we go to factor then, we're going to draw in two sets of parentheses because our goal is to get it to be something times something. And so with this, we need an x in the first position so that we get an x squared out. And then I need a minus 3 and a plus 5 per these numbers that we found down here, because these will multiply to be negative 15 and they will add to be the positive 2x. And so that's how we could factor this out in order to then be able to find our x-intercepts. So that's what we're going to be doing in this lesson. So this is something that takes a little practice and some getting used to. So let's look at a few more examples that I'll walk you through before you try out your own in the Now You Try problems. So we want to find the x-intercepts of the following trinomial functions with leading coefficient of 1 by factoring. So what do I mean by that leading coefficient of 1? I didn't necessarily talk about that yet. So that is the number in front of the x squared. And it's not shown to be a 1, but it is, right? Because 1 times x squared just equals x squared. So it's redundant to write the 1, however, it really is there. So that's what we mean by a leading coefficient of 1. Okay, let's take a look at that first example here. Part A, f of x equals x squared plus 5x plus 6. Our goal is to factor this to find the x-intercepts. So I'm going to write parentheses times parentheses. I need an x in the first positions, and then I need to take the number 6. So step 1 is we're writing the parentheses times the parentheses, putting an x in each location. The second step, I'm going to take the number 6, and I'm going to look at how it factors. I can do a 1 and a 6, or a 2 and a 3. Now I want these to add to 5, and they should both be positive because this is a positive 6. Remember, pay attention to the signs here. If we had a positive 1 and a positive 6, this would be a 7. If I have a positive 2 and a positive 3, that's a 5. So that's going to be our answer here. We wanted a positive 5, and that's how we can get it. So when we factor this, this will be a parentheses x plus 2, close parentheses, open parentheses, again, x plus 3. So now when finding the x-intercepts, we can say 0 equals, actually before I do that, let's go ahead and just check this. So this is not something that we normally do in practice, but just to show that this is going to work, x plus 2 times x plus 3, if we FOIL it, we would get x squared plus 3x plus 2x, and then a plus 6. And that would add up to x squared plus 5x plus 6, just like we wanted. All right, so now let's find the x-intercepts. Per request in the problem, 0 equals x plus 2 times x plus 3. So we're setting the y equal to 0. To find the x-intercepts. And this tells me that x plus 2 equals 0 or x plus 3 equals 0. Solving for x in both of these, we get x equals negative 2 or x equals negative 3. So the x-intercepts are negative 2, 0 and negative 3, 0. All right, let's see if we can get this to work out a little bit faster now. For g of x, I have g for the part B. G of x equals x squared minus 10x plus 24. So we're going to say that this equals parentheses times parentheses, put an x in the first position of each. We're going to look at the number 24. We want to find its factor pairs, so we've got 1 and 24. We have 2 and 12. We've got 3 and 8. We have 4 and 6. These are all of the factor pairs for 24. And we want to find 2 of them that add up to negative 10. The goal is to get them to add to negative 10. And they need to multiply to be a positive 24. So let's be really careful here. If I did a plus 2 and a minus 12, this would add to negative 10. However, that would multiply to be a negative 24, so that would not work. We could do a negative 2 and a negative 12, and that would be a negative 14, so that those do not add to negative 10. Instead, we want to go down lower. The minus 4 and a minus 6 would multiply to be 24, and it would add to negative 10. So that is our winning combination here. So I can plug in a minus 4 and a minus 6 into our parentheses, and that's our factored form for g of x. So if we want to find the x-intercepts, we'll set y equal to 0. and we'll get that x minus 4 equals 0 or x minus 6 equals 0. This gives us that x equals 4 or x equals 6. So the x-intercepts are the points 4, 0 and 6, 0. All right, so hopefully you're starting to get a feel for this process here. And we've got 2 more examples before we hand the reins over to you to try out some stuff. So let's take a look at this next one. For part C, we have capital H of t equals t squared plus 2t minus 24. We'll look at factoring this. So we'll write equals, parentheses, times parentheses. We know a t can go in the first positions of each parentheses. I'll then take the negative 24 and look for its factor pairs, 1 and 24, 2 and 12, 3 and 8, 4 and 6. We want these to multiply to be negative 24, but add to be a positive 2. So we want one negative and one positive. If I did a negative 1 and a positive 24, that would be a 23, so that's much too big. Negative 2 and positive 12 would be a 10. Negative 3 and a positive 8 would be 5. Negative 4 and positive 6 would be 2, so that looks like our winner there. So if I put a minus 4 and a plus 6 into our parentheses, then that's the correct factorization of this trinomial. If we FOILed it back out, we'd get t squared plus 6t minus 4t, and then minus 24, and the middle terms would add to 2t. Let's set this equal to 0. So we get t minus 4 equals 0, or t minus 6, or plus 6 rather, equals 0. So t equals 4 or negative 6. So we can say that the t-intercepts, not x-intercepts in this case, are the points 4, 0 and negative 6, 0. All right, let's do this last one here. We have capital K of t equals t squared minus 3t minus 18. All right, equals parentheses t, close parentheses, open parentheses, t, close parentheses. And I got the negative 18 that we want to find as factor pairs for. We have 1 and 18, 2 and 9, 3 and 6, 4 doesn't go in, 5 doesn't go in, and so I think that's it. That's all of our factor pairs. Note that I'm doing this in order. I'm checking 1, then 2, then 3. If any of those didn't work, I would just skip them and do the next whole number. And then I know that I'm done after checking 4 and 5 because 6 shows up in the next column. So I want to find 2 of these numbers, one positive, one negative, because that's a negative 18. And I want them to add up to a minus 3. So if I do a positive 1 and a negative 18, that would be a negative 17. If I did a positive 2 and a minus 9, that would be a negative 7. If I did a positive 3 and a minus 6, this would be negative 3. And so we can plug in then a plus 3 and a minus 6 into our parentheses to get our correct factorization. Real quick before we continue on with this problem, let's note that if none of these worked, then we couldn't factor. And we'd need to use the quadratic formula. Which I know at this point everyone's probably more familiar with the quadratic formula and feel more comfortable with it. But once you've learned this factorization problem, when it does work, it is so much quicker and easier than that quadratic formula. So it really is worth the time and effort to get good at this. All right, so we can set this equal to 0 to find our t-intercepts, and we'll get t plus 3 equals 0, or t minus 6 equals 0. So t equals negative 3, or t equals 6. So we have our t-intercepts are the points negative 3, 0, and 6, 0. All right, that's all we're going to do for this video. We've got some more problems for you to try. Go ahead and look at those now. You try problems. Give them a shot. Solutions to those. Thank you so much for watching, and we'll see you in the next one.